Okay, this quick clip is designed to help you predict what you will make at the electrodes. So we're going to call it predicting the products of electrolysis. And we're going to sort of produce almost a key to help us decide. So first question, whenever you're predicting the products of electrolysis, you need to talk about the electrodes separately. So the first question you should ask yourself is, which electrode am I talking about? So we obviously will either have the product at the anode, which remember is your positive electrode, or you'll be talking about your cathode, products at your cathode, which is your negative electrode. Okay, so let's talk about the anode first of all. After you've decided that you're going to look at the anode, you have to ask yourself whether you have got in that solution a halide ion or a halogen. So is there a halogen there? Now lots of you might be thinking, what's a halogen? And a halogen is anything in group 7 in the periodic table. So we're talking about chloride ions, fluoride ions and bromide ions. And remember, these will all be attracted to the anode because they've got a negative charge. So if you've got a halogen present and you say yes to that question, then this will form. This will be your product. If the answer is no to that question, so if in your solution or your molten liquid, if you haven't got halogen, if you haven't got fluoride, chloride, bromide, probably the examples that you'll get given then, it will probably be because you've got a sulfate ion present, which is SO4 2-. And if that's the case, then oxygen will form. So just to run through that again, you ask yourself which electrode. We decide we're going to look at the anode. We ask ourselves, is there a halogen present? So is there fluoride, chloride or bromide in the solution or the liquid? If it's an answer yes, then these will form. If there are no halogens present, then probably you've got sulfate ion and so oxygen will form. Okay, now let's look at the cathode. So the cathode is negative, so it's going to be attracting positive ions. So the first question you'd ask yourself about the cathode is, have I got a solution? Am I doing my electrolysis on a solution, or is it just a molten liquid? That means, is it melted? Is it just melted? So is it a solution or is it molten? If it's a solution, then it means you've got H plus and OH minus ions present. And the reason you've got those is because they together form water. And in solution, it means you've dissolved something in water. Okay, so once you know or you've thought about whether it's in solution or molten, you need to decide whether your metal ion, so the metal ion, so it might be copper or iron, any metal ion, whether it is more reactive than hydrogen. And the way to find that out is, so if we get to this question and we ask ourselves, is our metal ion more reactive than hydrogen? And if we say yes, then we can say that hydrogen is made. If we say no, our metal ion is not more reactive than hydrogen, then the metal gets made. Is made. Finally, if it is molten, so if it's not in solution at all, then this is really easy. We will just make the metal ion. So the metal ion is formed. So that's a nice simple one. So in an exam, if you get a question on something that's molten, you should be pleased with that, because that's always the most straightforward of electrolysis examples. So let's just whiz through the cathode again. So we ask ourselves, which electrode are we talking about? We're going to talk about the cathode. We ask ourselves, is it in solution? And if the answer is yes, then we've got H plus and OH minus ions in there. And we ask ourselves, is our metal ion more reactive than hydrogen? If it is more reactive, so if the answer is yes, then hydrogen is made. If it's not more reactive than hydrogen, then the metal gets made. And finally, if we're not in solution, if we've just melted our ionic compound, if it's molten, then it's really straightforward, the metal ion gets made. And that, if we follow this key completely, we should be able to predict any products that get made in any example of an electrolysis. We have a look here at the reactivity series. So let's say we are talking about zinc, for example. So we've got zinc and hydrogen ions in our solution. And we need to decide what gets made at the cathode. Well, we look at where they are. Now, zinc is higher than hydrogen in the reactivity series, which means that hydrogen gets made at the cathode and zinc does not. However, if we were talking about copper and hydrogen and we had to decide, is it copper that gets made or is it hydrogen that gets made? Well, in this case, it would be copper that gets made because the hydrogen is more reactive. So we always go for the ion that is less reactive than than hydrogen or hydrogen itself.